Hi, my name is Eva Eugene, and today we're going to talk about stem cell research. So, what is a stem cell? A stem cell is a somatic cell that works as a repair system of the body. It can build itself into something different to perform a specific function. So, there are different types of stem cells. There's the embryonic stem cell, the perinatal, the adult stem cell, the induced pluripotent stem cell, and cancer stem cells. The embryonic cells are the most controversial. They are extracted through in vitro from an embryo within the first 3 to 5 days of fertilization. The perinatal cells are extracted from amniotic fluid prior to or immediately after birth. There's no harm done to the fetus or the baby, so this one is less controversial. Adult stem cells are less controversial. They are extracted from bone marrow or through adipose tissue from consenting adults. The induced pluripotent stem cells, or iPS cells, are a little different. They too are extracted from consenting adults. However, in 2006, this technique was discovered to be used to be a little bit more comparable to embryonic cells. These cells, these cells are reprogrammed so they can be a little more flexible and useful in different parts of the body. Cancer cells are the least controversial of all because these stem cells are extracted to do research for discoveries for solutions. They help to create solutions for tumors and cancer. Now that we understand the different types of stem cells, now let's talk about their functions. Pluripotent cells are the most flexible. They are unlimited and can be used on any function of the body. They are derived from embryos, so they can regenerate and repair diseased tissues and organs. The pluripotent cells, they are a little more limited. However, they can also form into different parts of organs of the body. However, they are not quite as flexible as the totipotent cells. The multipotent cells are the least flexible of all. So, why stem cells? Well, let's see what stem cells can do. The most commonly used are the mesenchymal stem cells, or MSCs. They are generated from fat tissue or bone marrow. It is used for orthopedic repair, pain management, arthritis, asthma, and many other applications. The HSCs are used, they've been used for decades to help build the immune system and also for radiation and chemotherapy. Other things that stem cells support is Parkinson's disease, spinal cord injuries, heart disease, cancer, asthma, all kinds of things. Stem cells are also used to help test drugs to make sure that they're safe and quality effective. David J. Fink, Ernest Hunziker, and Frank P. Berry did research on a knee injury where they injected one dose of stem cells into a knee and researched it for 6 weeks. And in those 6 weeks, they definitely showed a response. They saw regenerated tissue, and actually degeneration had began to subside. And have the tendency to form tumors. The pluripotent and the multipotent cells, they have potential to create growth in the wrong tissue. And being that the ISPs have been manipulated in a laboratory, they can be a little bit unpredictable. Being that adults have lives for a little while, our stem cells are not going to be as promising and as versatile as the embryonic cells. Adult stem cells, they might have issues because of the environment, and they may have a little bit of toxins or maybe even have some errors along the way because of the replication. And the embryonic cells, they might trigger the immune system and might have to fight back. Being that we have all these drawbacks, or have risk at least, there's going to be some legal issues. So you have to think, what's going to happen if we have an effect that might be a little bit negative? We have to have control on what's going on with these different systems. And the great thing about it is that the US FDA, they already have control. So they created different systems to control what's going on with stem cell research. The 361 product says that you have to have a license to be able to have these functions, control these functions. Also, it has to be approved by the FDA, and it's regulated under Section 361 of the Public Health Service Act. 351 says, okay, they have to be a little bit safe about what they're doing. So they have to demonstrate safety and efficiency and are regulated and regulated as drugs. They are regulated as a drug, as a device, and as biological products. So that means they are controlled by the drug FDA, by the FDCA, Food, Drug, and Cosmetic Act. In 2001, Ronald Reagan signed to have federal funding stopped for stem cell research. However, in 2009, President Barack Obama, he removed some of the restrictions on embryonic stem cell research. With all those medical issues and legal issues, of course, it's going to bring in some ethical issues as well. And being that a lot of the stem cell research in the earlier days were done on embryonic cells, it became a problem and brought up questions through many human beings. So let's talk about some of them. National Institutes of Health created guidelines for human research in 2009. The guidelines define embryonic stem cells and how they may be used in research, and included recommendations for donations for embryonic stem cells. The guidelines state that the embryonic cells could only be used when the embryo is no longer needed. So let's talk about some of the ethical questions. Does human life begin at fertilization, in the womb, or at birth? Is a human embryo equivalent to a human child? Does a human embryo have any rights? Might the destruction of a single embryo be justified if it provides a cure for countless other human beings? And since ES cells can grow indefinitely in a dish and can, in theory, still grow into a human being, is the embryo really destroyed? I guess the answers to these questions.
When it comes to research, I believe that you should take the time and think for yourselves. I personally believe that if it's saving someone's life and not harming another, it's something that we should probably explore. What do you think? My name is Eva Eugene, and I'd like to thank you for watching my video.